Good morning, sir. I welcome you to our presentation on goals of distributed system. This presentation is presented by myself, Anushka Harshavadan Nevgi, and two of my classmates, Ameya Amanagi and Parth Medhekar. Now, before we start with the definitions, let's think about the apps which we use every day. Google Drive, Netflix, Amazon Prime, and even online banking systems. All of these contain distributed systems running in the background. The idea of distributed system is quite simple. It is instead of one big computer doing all the heavy work, we connect many smaller computers together. And to the user, it is just one big powerful system. Now let us understand the definition of distributed system. As it says, a distributed system, it's a collection of many independent, that is autonomous computers, and they communicate with each other by passing messages. This system is also called as a coherent system. Now, what's the interesting part? The interesting part is that even though many computers are connected, many computers are involved in a distributed network, but to the user, it is just one big system. It is like a group project. Now, even though group project is done by dividing the task, in the end, it is presented as one big project. That is nothing but a distributed network. Here, we can see how the distributed network is consisted of. It consists of multiple computer systems connected to a centralized system, which conducts many activities with the help of distributed system software, which consists of its own database. This is the structure of distributed system. Now, let's take an example and understand the working of a distributed system. Let's consider the case of uploading a file on Google Drive. So to do that, first the user interacts with the application. This is nothing but the user interaction. Now, after the user interacts, each node processes its own part. Like as you can see here, there are multiple computer nodes connected, and each of them will process their own part. Like one might consider storing, one might consider different computations. So these processes get divided among the nodes. Now, the middleware, it makes sure that the nodes are, talking to each other. They communicate with each other with the help of message passing. So that is done. That is, it is made sure by the middleware. Then comes the network. The network carries the actual communication. It actually carries the message which is transferred between the computers. Then lastly, all of these outputs are integrated and it is shown sorry, to the user as one complete service. So even though there are multiple computers, as we can see, multiple computers working behind the scenes, the user only sees one final result. Now, further to explain the goals, I would like to call my friend Parth.
Thank you, Anushka. So we'll see what are the different goals of the distributed system. First is the boosting performance. Second is enhancing reliability. Third is scaling for the future, and fourth is resource utilization. There are different objectives and additional approaches. First is the consistency and transparency, fault tolerance and resilience, security and data integrity, and last one is the load balancing. Firstly, we'll see about what is boosting performance. Boosting performance, the distributed system tries to make the things faster by dividing the bigger tasks into the smaller units and chunks and processing them simultaneously on different computers. It's just like a group of people working together on a project. So the example is in this, the task is only one task is created, and there are two separate threads that are executed at the same time, and it prints that which thread is running currently. Then next is second is enhanced reliability. The distributed system ensures the reliability by minimizing the load of individual computer failure, and if one computer gets failure, then the other one tries to keep the system running smoothly. The example is, so in this it tries to connect up to 3 times. If it succeeds, the loop will stop, in the for loop will stop. Otherwise it retries the maximum attempts, and then it stimulates the automatic recovery, and which improves the reliability of the system. Next is the scaling for the future. The distributed systems are experts at handling the increased demands. They manage the demands by incorporating more and more computers into the system, and they run the system very smoothly and can handle more users. So in this, basically, there are two strings in which first is the users and second is the servers. In users are connected to different servers. If new users come, they can be assigned to available servers, and it increases the scaling. Then last is the resource utilization. It is one of the most prominent features of the distributed system. It ensures that work will be done by utilizing every resource. In this, there are two strings made. First the task and another is the node. The tasks are evenly assigned to the nodes. No single node is overloaded, and it improves the efficiency and system throughput of the system. So next will be continued by Ameya.
Thank you, Parth. So now let's look at the benefits and challenges of distributed systems. Starting with the benefits, first one is scalability. Distributed system can easily scale up. If the workload grows, we can simply add more nodes to handle it. Second one is resource sharing. They make efficient use of storage, processing, and data across multiple locations, but nothing goes wasted. Third one is improved performance. Since tasks are processed in parallel, execution time and delays are reduced significantly. But along with these benefits, there are also some challenges. The first challenge is complexity. Designing and managing the systems is not easy because all the coordination and the synchronization needed. Second one is security, ensuring that the data is continuously moving across the network, so keeping it safe and ensuring its integrity becomes difficult. Third one is data consistency. With multiple replicas of data across nodes, making sure everything stays accurate under concurrent access is quite challenging. So, in short, distributed systems give us powerful advantages, but they also demand careful handling to overcome the challenges. Next one is, let's make this more concrete with a couple of real-world examples. The first one is Google Drive, which is built on the Google File System (GFS). Here, the files are broken into chunks and stored across the multiple servers. There is replication for fault tolerance, meaning even if one server fails, our files are safe on another servers. This also support the big data application and large-scale cloud services. The second example is BitTorrent, which is based on peer-to-peer file sharing. Unlike centralized system, BitTorrent uses a decentralized sharing protocol. It's highly efficient in resource sharing because users download different pieces of a file from multiple peers at the same time. Data transfer is non-sequential, meaning we can receive the different parts of a file simultaneously, making downloads faster. It's also scalable and resilient. So, both Google Drive and BitTorrent show how distributed systems are applied differently, one for cloud storage and other one for file sharing. But in both cases, they highlight the power of distributed computing. Next, so wrap things up, distributed systems power almost every modern application today. They provide scalability, reliability, and efficient resource utilization, which are critical in today's data-driven world. Yes, they come with challenges like complexity and security. They remain the backbone of robust future-ready solutions. So whether it is a cloud storage, streaming platforms, or peer-to-peer networks, distributed systems are the invincible force that keeps our digital world running smoothly. Thank you.